Good morning, people, and welcome to the first episode in what's going to be a new series. A leopard's frazzled because occasionally sparks happen, fur flies, etc. Yes, this is going to be a series looking at electronics for model railways. I'm going to be starting out with a little look at some microcontrollers. This is going to be a mixture of cellar stuff and desk-based. So let's get down to the cellar and we'll start having a look at this. Welcome aboard. Okay, hello. This is something slightly different. I've got my little desk area here I can play with now, so I'm going to play with it. This is the start of a little series I'm going to do on microcontrollers and electronics for layouts. If you want discrete circuit stuff, there's going to be a little bit of that. I would suggest, however, Train of Thoughts channel. Ian is very, very good at that sort of stuff. So what we're going to look at are things like this. And it's hard to see because it's inside a case. This is an Arduino Nano. So on the end we have USB connector and a barrel jack for putting power in. It'll power off USB, so you can plug it into a computer, which you basically need to do to program it. It's a little computer. They're not very powerful, but they are quite good. They're designed specifically for controlling things. So if I just find a piece of paper, I'll explain what I mean by that. Zoom out slightly. See the mess that is under my desk. I'm going to just move a couple of boxes so we can possibly get a tad close to the table. There we go. Now, first question. What are you wittering about? What is a microcontroller? Well, think about it as you have a problem to solve. What you have is an input of some sort. That could be a switch, say. It could be a sensor. Doesn't matter what it is. It's a switch. That is going to produce an output. That could be a digital output. It could be an analog output. You don't know, could be. And over here, you have an output. Another thing. This might be a light. This could be a servo motor. It could be a normal motor. It could be the input to something else. And in the middle, you have a thing. And the job of the thing is to take that input and in some way generate that output. That is maybe very simple. A switch to drive a light, it's a bit of wire. But you might want that light to come on if 2 or 3 switches are correct or in a certain configuration. You might then use some logic gates. It starts to get a little bit more complicated if you've got multiple inputs, multiple outputs, and you want to work things in different combinations. That's where one of these comes in. It's programmable. There's a little microchip that lives inside this thing. Not all of these pins are, some of them are power wires, which are some of these ones, basically these ones down here. But these wires up here, these pins up here, these can be inputs, they can be outputs. There's some down here that can read analog signals. You can do things with it. You can program it to do what you need. You could have a switch that when you press it, triggers a servo motor, which I don't have to hand, but press it again, the motor goes back to its previous position. You could have 2 switches, one that makes it go one way, one that makes it go the other way. You might want a light to come on at the same time, or to drive a relay. Lots of things. These little things can do it. It's basically, think of it as a computer designed to control things. That one's about as basic as it gets. Like I say, I've put that in a little enclosure. It's got some little rubber feet on it. to sort of bench proof it. There are some little lights in there if you power it up. You have others, and there is this one, an Arduino Mega. Zoom back in again. This is basically the same thing, but it's more powerful. It's got more pins for things coming in and things going out, all of these. It's got 16 lines where it can take analog information in. That's like a varying voltage. There are limits. These things work on 5 volts. This one's got a bit of wire stuck to the bottom of it. Not sure how that's happened, but anyway. But they do different things. This one's slightly more powerful. For example, Leopard Street, the DCC EX system is one of these. Driving the entire layout. All the commands to drive the trains goes through one of these. Drives a little screen. There's this one, which looks very similar to that. A lot more powerful. This is the Arduino Duo. It's a different chip. Annoyingly, it runs on a different voltage. This uses 3.3 volts instead of 5 volts, which is a little bit irritating. This is a much more powerful machine. The computer runs a lot faster. It's got a lot more memory on board, a lot more capable. Drives screens and things with that. Then we have this one, still in its packet. This is an ESP 8. It's either an 8622 or an 8266. I can't remember off the top of my head. Obviously quite a lot smaller. This one doesn't have very many pins on it, so it's not as capable in some ways, but it's got wireless. So your output, and for that matter your input, could be talking over wireless to a computer, to something else, to another one of those. We have this, again in its packet. This is an Arduino Nano. It's basically one of these in a smaller package. It's also designed to stick onto breadboard. We'll come on to that in a sec. It's slightly more capable because it's got an extra 2 analog inputs. Other than that, it's exactly the same. Slightly different chip on it. Then we come to this one. This is quite a clever one. These are a bit more recent. This is the Raspberry Pi Pico. You may have heard of the Raspberry Pi computer. This is by the same people. This is a microcontroller. Again, 3.3 volts. When these first came out, these were quite hard to use. All the rest can be programmed via an interface called the Arduino Integrated Development Environment, IDE. Very simple to use. This couldn't. It now can, which made them a little bit more of a pain to use. These are very powerful though. Maybe not as powerful as the next one, but very powerful. And this, unlike the rest, which are all clones bought on eBay, this is an original. And when I got these were about £3 each. You get to the point, when we start looking at some of the logic circuits later, there are things like, I need to talk to a keyboard. And you think, well, how do you talk to a keyboard? And what you get is there's a microchip which lets you talk to a keyboard so that you can feed it into one of these things. That chip can be 8, 9, 10, 15 quid. Get another one of these. Connect that to the keyboard. That sits over there. This one sits here and they talk to each other. Very cheap way of doing things. Then we have this one. These are the sort of ones I use a lot. Leopard Street's driven by these. These are ESP32. So this is a 32-bit microcontroller. Again, it's got Wi-Fi. This particular one's got a screen built into it, which is quite nice. And you pins around the sides of it. These are quite powerful. They've got, I forget exactly how fast they run. They're good. They've got a fair bit of memory on board. I think this has got 4 meg flash memory. And quite a bit of memory you can stick code yourself in and variables and other bits and pieces. We'll come to that when we look at the programming. We have also this one. Now this is quite interesting. This is another ESP32, but it's got built into it a battery holder. This holds, I think it's an 18650 rechargeable battery. And this board has all the circuitry it needs to recharge the battery and a little on-off switch. Slightly annoyingly, the on-off switch is on the board. It'd be nice if you could use little pads you could solder your own one to. And same with these connectors. They're on the board, but they're in an annoying space. And these pins are really annoying how they're fitted. But they're quite useful if you want to make something battery powered. So how do you use these things? Well, get paper out of the way again. Start with this stuff. This, for those of you who've not seen it, is a breadboard. Use it either way around. And what you've got inside this, if I just find a pointy stick, railway, I'll use a piece of rail. You've got rows of holes here. Now these 5 here are connected together. These are connected together. They go in strips this way. And then these end ones are connected along. Annoyingly, there's a break in the middle there. Don't quite know why. Get the good breadboards, you don't get that break. And this stuff, use it for prototyping. Now what I'm going to do, I'm going to make a slight modification to this, because I am going to cut, they come with self-adhesive backing, which is quite nice. And what I'm going to do is cut through that on this one. I'm going to try to. It'd help if I had a knife sharp enough to do it to hand, but there we go. There we are, that's gone through. So that'll come off here. Zoom back out slightly so you can see what I'm doing. At least it would come off here if it had actually cut through it properly. There we go. There we are. So that comes off like that. You can get rid of it. And what I now do is turn this piece the right way around, and it's got these little interlocking tabs. And I can do that, a larger one. And this piece I'm going to put at the top because it might prove useful. Might not, but I'm going to put it somewhere. The reason I've done that, this little Arduino Nano will sit in the middle quite happily. These ESP32s, and basically that'll sit, and you just plug them in and then they sit in. This little swine, however, won't. It'll just about fit in there, but then you can't connect anything to it. So what I tend to do is stick 2 of these boards together, and you can put these on here, and what you get is 2 holes to either side of it. So I've got these 2 holes here I can use for these pins, these 2 holes here I can use for these pins. So if I press this in, I'm just going to do this slightly to the side because I need a flatter surface I can press down onto in order to do this. And that's that in there. Now you don't have to power this thing up, but it's a little, what does it do? There's a few other little bits that are worth doing just to get this ready. And this is going to get this board ready to do something with it. So what we now have is this. This is single core wire, frequently called hookup wire. Again, you can just cut into it fairly easily. But this is single core. The good thing about this is this will pretty much stay where you put it. So what I'm going to do is I'm going to say the blue tracks are going to be ground, which is the negative connector. So I'm going to cut a little bit of this. I'm going to strip the ends just slightly. Very straightforward to do. And I'm going to bend them so it looks like a big long staple. And then I'm going to come over here. Well, yeah, for now I'm going to come over here. Eventually these wires will come over to the end, over here where they're out of the way. That sits in there. I want a red one to go next to it, which is going to be positive. This is because I'm going to switch this on in a minute. I'm going to switch it on using wires. I'm not going to switch it on using the USB port because I don't have a USB port readily to hand over here. Rather remiss of me, but there we go. So I'm just going to trim these off. If you've seen me stripping wires before, you'll know I use wire cutters for it rather than wire strippers. Using what I've got, basically. So that can go into there, that can go into there. These ends are probably a little bit too long, so I'm just going to shorten those down a bit. Basically, I don't want the wires sticking up too much. There we go, that's that one in. And that one's in. And if you look on here, if we zoom in, you can see these pins are all labelled. So what we've got on here, let's turn that around so I can see it. Now we have V in, which is a 5-volt line, and ground, which is a ground line. I said these things run on 3.3 volts. Well, their input voltage is 5 volts, and it's 5 volts because this thing wants to run on a USB port. So I'm just going to set this up with some connections, and then we can power it up and we'll see what it does. What it should do is the screen on it should light up. This is one I haven't used before, so the screen should light up with whatever the manufacturer has told it to do, and we will find out. So that then goes from there to V in, which is that one. You have to push these down. Sometimes they go in better than others. So you just need to persuade it sometimes. And by persuade, I don't mean a hammer. Although, trust me, that does get very, very tempting sometimes with these things. So we're just going to have a quick little look. But yeah, so why would you want these things? Well, it is all really about programming logic. I mean, simple little things. You may have seen some people have done traffic light sequencing with various boards. Well, say you don't want the traffic lights to run on the timed sequence that somebody else has programmed. And maybe you do, maybe it doesn't matter to you. But maybe for some reason you want them to be a little bit different. Integrated with a level crossing, maybe. Well, if you use one of these things, or a microcontroller of some description, you are in control of what it does, which can be quite useful. So that's in there, that's in there, that's in that. Right. What I now need to do, zoom back out slightly, I need to connect to this board over here. Now this has a 5-volt logic line and a ground line, which are perfect for this sort of thing. So I'm now going to just make myself a temporary connection. It's not going to be a very big piece of wire, it doesn't need to be. Somebody using the stairs above me. Ooh, scary, the stairs are being used. I am going to make a proper little power lead for one of these things eventually. But there we go. So that is there. Strip the other end. That. And what we're going to do, let's come over here. Undo that screw. Undo that screw. And this is where I'm just going to make the red one of these while I'm doing it, because I can get the same length in. This is one of these situations where I don't use connectors. So I'm not going to put crimp terminals on these. This is a very temporary little setup. But there we go. Now, I say there's all sorts of things you can do with these. You could do lighting. Spoiler alert, when I come to put lights in the cinema, a microcontroller will be used because of the lights I'm going to be using don't work by just plugging them in. They need a controller of some description. You may have seen similar things. People use them in kitchens. I use them in the kitchen here. We have LED lights that you can change the colours on. And doing that requires a controller of some sort. So if I just clamp that onto there, that will give me 5 volts when I turn it on. This will give me ground. And if people are actually interested in that sort of level of electrical fundamentals of what on earth does ground mean and all this sort of stuff, let me know in the comments. If enough people are interested, I will have a look. There's a lot of information out there on this sort of stuff. I'm sort of going to be approaching this from a model railway point of view of what's worth knowing for model railways. Hence that you can't see them, but there are actually trains in the background here, although they're not running. Right, so what I need to do now is turn this on. So my little remote here, and channel A is this. There we go, powering up. Is the screen going to do anything? There we go. Needless to say, it's upside down, because of course it's upside down. There we have, that is now powered up. It says it's radio frequency. Idea Spark is where it came from. It's got power, that's what that little power light is. There's a little blue light on here which you can use, but it can cause problems. This is one of the compatibility things you have to think about with these things. It will usually send that blue light bananas when it's trying to connect over the Wi-Fi. But then there's a little screen, and it's, I think, 128 pixels that way, 64 pixels that way, and you can put anything you want on there, as long as you don't mind the top bit being in yellow and the bottom bit being in blue. Done. I could put one of these on here, I can make them talk to each other. You can make these things do all sorts of things. At the moment, that is literally all it's going to do. We're going to make this do some more stuff in the next video, but this is the starting point, this little board. I'm going to do some little bits. I'm going to bridge all these pieces across, and I'm going to get the power going all the way across on the board. But we'll be back in the next one, and what we're going to do is look at giving this some inputs. We're going to look at how you program them, and we're going to get to say hello and lighten an LED up or something and monitor a button. Show you the real basics on this stuff, and get it to say hello, because it's got the screen built in. I might as well use it. That's it for this video. If you've enjoyed this, likes, comments, subscriptions, all helps the channel. Subscriptions are free, likes are free, sharing with your friends is free, laughing is free, commenting is free. Please feel free. Meanwhile, I'll catch you in the next one. Thank you very much for your time, and I hope you enjoy the rest of your day. Thank you very much, and goodbye.